Hello and welcome back to our next lesson where we're now looking at another way to represent the quadratic function. But this lesson should actually be a review because we have been seeing this representation and using it. We just haven't maybe necessarily given it a correct name. So we are looking at now the standard form, which is pretty much in that factored form. So I probably have used factored form a lot more, but that is uh, this representation right here. So today we're going to be looking at converting between the standard form and the factored form, and also again looking at their graphs. And now we have seen multiple representations, so we're going to be doing a lot of comparisons between the different forms, and you will determine which one is best for you to use, which one you find easier, which one you're more comfortable with, and which one is best for different real world problems. So our factored form is that form A times x minus r and x minus s, which r and s are the zeros of the relation or the function. So zeros of the relation are pretty much when values of x for which the output is zero, or as we know, it's when the graph intercepts the x-axis. So now, starting with this first function, we are asked to determine the coordinates of the vertex. So by now, we should know that when we need the vertex right away, we're just going to switch to vertex form. And then we're going to also graph this. So first, using the decomposition method, we want to find two integers that their product is negative 24 and their sum is negative 5. So this will give us negative 8 times 3, and then we can also check negative 8 plus 3 is negative 5. So now we can write this as 2x squared minus 8x plus 3x, and we are going to use decomposition here and verify that your factored form will be equal to this. So now to determine the vertex, we want to know where the roots are so that we can from there determine the axis of symmetry, which gives us the x-coordinate of the vertex. So to do that, we're going to look here. So our x-axis, our x-intercept is pretty much when this function is equal to 0. And for that to happen, we either need this bracket to equal 0, so x minus 4 is equal to 0 will give us x is 4, or this bracket is equal to 0, which in this case will give us negative 3 over 2. So kind of picturing it now on an axis, we have x is 4 there, and we have negative 3 over 2 about here. Our axis of symmetry will fall in between these, and we will have our vertex on that axis of symmetry. So to find that, we are going to have 4 plus negative 3 over 2, and we're going to divide this by 2. So we're pretty much finding the average because the axis of symmetry is um, pretty much the average of the zeros because it falls in between both of them. So here we get 5 over 4. And that division by 4 is, that division by 2 is also times half. So if you're more comfortable with fractions, you should have got that answer. And now here, you are pretty much just using the formula that you were given in the start to determine the output value. So we already know this is 5 over 4. You can also write this in decimals at this point, especially if you're using a calculator. So 1.25, and then you should get negative 15.125. And this actually works out because we had A as 2, which is greater than 0. So our parabola is opening upwards so that we will have, if we are going through these points, we would have a minimum. And that checks out. This is approximately that negative 15. And now to graph it, we are going to find the y-intercept. So y-intercept is when x is 0. So f of 0 gives us negative 12. So our y-intercept has the coordinate 0, negative 12. And now, knowing the axis of symmetry is at x is equal to 1.25, so x is 1.25, how can you find another point on the parabola that has that um, output value of negative 12? So if you're looking at my mini sketch here, so this is just a sketch. We don't consider this as the official graph, and we'll do that in the next part. I have a graph for you. So over here, if I have this point here, 0 to my axis of symmetry is one distance away, or sorry, 1.25 distance away. So then my um, equal point has to be 1.25 away from 1, which will give us 2.25 negative 12. So take a moment to verify that if it's not clear. Sorry, this should be 2.5 because if we have this as my axis of symmetry, x is 1.25 and we are at 0 here, then going that same distance apart here would give me 2.5. So think of like the number line. So now I have 5 key points and I can start to graph. So try this on your own now to graph this and then come back and check your answer. Okay, so that's my graph here. I did have to change the axis scaling on my y-axis because it only went up to 10. So just consider the ones that I wrote, not these ones. Should be negative 18. Okay. And I plotted my two x-intercepts first, my 2 points that I just found, and my vertex, and I connected them all, and that's a sketch of my function, or my parabola. And one last thing, and don't forget this, we will label x and y, and these graphs that I have copied for you don't come with that, so make sure you are labeling them. Now, looking at this next example, we are given a function and asked to use decomposition to write it in a factored form. So try this now. And right away, I hope you see that we can factor out that 2. And now this will be can be written as such in factored form. So my x-intercepts are going to be x is 3 and x is 1. And my y-intercept we get from when x is 0. And if you set x to 0, you get y is equal to 6. So that's your x and y intercept. Pretty simple. Now we're given two representations of a quadratic, and we're asked to algebraically verify that these two are the same. So you can either try decomposition for the standard form and get the factored form, or the simpler way would be to expand that factored form and see if you get the standard form. So this will be, so I'm just gonna use FOIL method to distribute the two brackets first, or expand the two brackets first. And then I will multiply that through. And you can see here that okay, so there was a negative missing there, so I've added it for the one that you're going to be using. But with that now, we should have gotten that, yes, this is actually equal to f of x. There we go. So then we can use that second part. So this is part A is done, we've shown. And from part B, we're asked to find the vertex using either form. So I hope that by now you have seen that because we are looking for that axis of symmetry where the vertex falls, it's easier to use the factored form. So from here, I know that my x values have to be 2 and 4, so that my axis of symmetry is going to be x is 3, which falls in between both of those, so that my vertex is at x is 3. So now you can use either equation, so I'll just use that second one. We get 3 minus 2 and 3 minus 4. So -1. And we'll see that this is equal to 1. So now classify it as a maximum or minimum. Because A is less than 0, we know that it is opening, our parabola is opening downwards. So this will be our maximum value at 3, 1. So it'll be a maximum. And state the axis of symmetry. So now we know right away, we already actually have that up there. Axis of symmetry is x is equal to 3. And we already have our x-intercepts found. So just our y-intercept left, which we get from f of 0 or um, g of 0. Now for this one, I will add, oh, well, no, f of, it's just y. But if we use that y function in this case, it's actually more helpful because the first two terms are just 0. So then our y-intercept is at 0, negative 8. Okay, and that's your final answer for that question. And the last question we have here, we are now just working a little algebraically first, where we're given the factored form and asked to expand or asked to oh my God, algebraically manipulate that equation to find B and C in terms of A, R, and S. So take a moment and try this on your own. So pretty much what we want to do is we want to take P of x and expand it. So we get x squared minus rx minus sx plus rs, and then distribute that a to get ax squared minus, and um, okay, let me go back a step because here I'm actually going to factor out. Okay, so don't let that confuse you. I just wanted a better coefficient for x, so that x is just written as one term, not two terms. And you can check that if we distribute this negative in there, we get the negative rx and negative sx. Now, finally, for our a value, we have ax squared minus a r plus s x and rs. So now, a is just a. B is negative a r plus s, and c is rs. So in part B, when you're given these values and asked to write this in standard form, we can just write, um, let me just do, I'm going to use f of x since we haven't used that here now, as 2, or hold on, one extra step here. So a is going to be 2, b is going to be negative 2, and then r and s here are negative 1 plus 3, and then c is just negative 1 and 3. So here we get negative 3, and here we would get negative 4. So then we have 2x squared minus 4x minus 3. And our last question, does the parabola open up or down? You can determine now from A, which is 2, and this will actually hold true for both the standard form and the factored form because A does not change. So here A is positive, so we know that it's going to open upward. So please make sure you explain that just by using A and correct mathematical vocabulary. And that's we're almost done our lesson. Just one last problem. So here we have a graph now, and you're asked to find the factored form or and the standard form just using the graph. So take a moment and try this, and I'll be right with you to give you the answers. Okay, and looking at our last example for this lesson, so from this graph now, we want to find the equation. So when you have the roots already, it's best to start with the factored form. So I've already identified my x-intercepts as x is negative 5 and 8. And so I will set up my factored form as x plus 5 and x minus 8. Keep in mind that they need to be the opposite signs so that when we set them to 0, we actually get that negative 5 and the 8. So now I will use any point to determine a because that's my only variable that's missing. And here I'm actually going to use 0 and -20 as my y-intercept because then I don't have to do anything additional for x. So here we get y is set equal to -20, um, which is also equal to a times 5 times -80, which will give us -40a. And from that, you get that a is half. So substituting that back, we get half of x plus 5 and x minus 8, which is just my factored form. And now you're told to expand to find the equation in standard form. So if you just do that, you will get the following. If you want an extra challenge, I would recommend now from the standard form, try to factor and complete the square to get that same, uh, uh, or sorry, factor to get the factored form. So using greatest common factor and decomposition method, and see if your answers will match. And one last question we have today is, what if there was only one x-intercept? So whether on the graph or you were told that there's one x-intercept, so write the formula, how would you have done that? So whatever your x-intercept is, let's say it is at, let's say this is 4, 0, and we have such a parabola. So then you would just write y as x minus 4 squared for a quadratic because that's our only x value. And that's a perfect square here as well with no constant. So then you would just have to find what a is based on any other points on the graph. Okay, and so just some practice for today for standard form. So this should be a bit of a review since we have been working with factored form. So just maybe focusing on connecting it to the standard form and the graphs, and again, which one you find easier and which one you may still have questions about. And I will see you all next class.